Hi, I'm Mark Krause, Vice President of Sales and Marketing at G Systems. A while back, I spent some time in the Marine Corps supporting artillery battery, specifically on the counter battery radar side. I got to fire a lot of fun weapons, a lot of sophisticated trajectory tracking equipment. But one day, the Army multi rocket launch system team rolls up behind us, and we're on top of a hill, and they start launching their rockets right over the top of our heads. It was a little bit scary at first, you might say, but over time, I got to realize I needed to trust the system, trust the training, trust the equipment. I never really got to meet the engineers that were behind it to make sure it was really safe. I never realized how complex and sophisticated something like that would actually be. I wonder how well it was designed and how well it was tested. Who was behind it? Somebody had to come up with that. Fast forward many years later, and now I have the actual honor to work for G Systems and actually get my questions answered. Today, I have the privilege to introduce Dave Baker. He's the Senior VP of Engineering and the manufacturing side. And let's ask him together some questions that I had at the time and see where this goes. I know that you've been here over 23 years. You got to support countless test systems, some of those related specifically to missile tests, which is what we're talking about today. The ones that come to mind are the NLOS system, GMLRS, which is, I believe, the gimbaled version of the MLRS system that I was talking about earlier in my experience. HIMARS, the Navy's Mark 41, PAC-3, ATACMS, and even some of the hypersonic stuff here recently. So maybe you can help us understand a little bit as it pertains to the missile test and the 23 years that you've been here. What are some of those changes that you've seen?
Right. Yeah. So there certainly have been a lot of changes. I would say probably one of the biggest shifts that we've seen is moving away from custom, specialized, designed hardware to more commercial, off-the-shelf hardware, and that's certainly been a trend over these years, both on the hardware side and the software side. That's been a trend that's been going on. Also moving towards components that are software customizable. We used to have a kind of a hardware, very custom hardware solution to something. Now we have a lot of systems that can be defined in software and customize them that way. And I'd say probably one of the biggest challenges is since things are rapidly changing over time and it's accelerating, keeping up in an industry that demands very sophisticated configuration management. Trying to do that with hardware that's changing very rapidly has been a big challenge for our industry. And then, of course, as things get more networked and connected online, then cybersecurity comes into the picture, and it's a big concern with things that are out there all connected together and communicating.
Yeah, especially with a lot of the off-the-shelf parts, STIG compliance is really an issue that we face a lot and
Right.
deal with.
Right.
So one of the holy grails of all test systems, especially missile tests, is can someone develop a test system, one test system that covers many different platforms? The cost savings, the efficiency, it just goes on and on. That seems to be the holy grail. A lot of people tried it and failed. G Systems has had a lot of good success in that. I'm wondering if you can talk about some of that success.
Right. So you do have customers that want to have a completely universal common core test system, and we usually steer people away from that towards a common core for a given application or a family of products that are being tested. So if I have a launcher that has a power system, a computer system, launch controls, maybe navigation, those types of things, we can usually package that into a common core tester for that system. So that has a lot of benefits in that you can still get commonality and standardization within that platform, even though that may not transition to exactly to the next system. Things that are enabling that, of course, are having interchangeable test adapters, cabling, and so forth that can swap out very easily. Things like Virginia panel that most people are familiar with, Mac panel, but also systems that we design, cabling systems and interface systems that we can design to kind of go that last mile, what I call that last mile. It also involves abstraction, both in software and in hardware. So in the software side of things, you would think about frameworks for running tests that can swap in and out test suites very easily. You might have abstraction in the hardware interface so that later, if I have a multimeter that goes obsolete and I need to be able to swap that out at some point, I can do that very quickly with a layer that supports that. Maybe it's moving from an engineering environment over into a production environment. So we have a lot of experience creating frameworks to be able to do that very easily.
Thank you. Yeah, when it comes to design aspects and design requirements, typically they're laid out very much in detail. And one of the forgotten things that I think a lot of us forget about is the end user, the warfighter, making sure it can be used in an easy basis with that end user warfighter in mind. Can you talk about some of that?
Right. So you're right. The customer, the typical user in a military and aerospace application is somewhat different than the commercial user. One aspect that's really important we find is having high reliability. So systems that really cannot fail when they go out into the field, especially. So if the warfighter is using the system out testing his system, he needs to have absolute confidence. And so we focus a lot on reliability, making systems that are ruggedized, like the system that is sitting behind us is one that goes out into the field routinely, comes back covered in sand. So it has to be designed to withstand shock and vibration and humidity and salt spray and all these things that it's going to experience that your typical test system sitting in a lab just doesn't experience. Yeah. And also very important is the user interface to tailor it to the operator that's going to be using it. If it's going in an engineering lab, well, you've got engineers that may be able to handle a more sophisticated interactive experience. If it's going into a typical warfighter's hands, this is a young, sailor, Marine that's out in the field. They don't have time to learn a very sophisticated interface, and they want it to be simple and reliable. And so that's a key design factor.
Yeah, that is really key. I remember seeing some videos of that unit actually being dropped off a 6-foot ledge. Why? Because that actually happens in a real environment, on purpose or not. It actually happens. Stressful environments. These warfighters are in extremely stressful environments. They don't have all the time to do what they need to do. Talk to me about some of the automated systems that we've set up to relieve that stress, to make it as quick and automated as possible.
Right. So I would say one of the most important aspects is being able to self-test, and that means having the unit be able to test itself. So that usually involves some kind of a loop back of the I/O that's going to connect up for the test system. Being able to run that in an automated way so that the test system itself has built-in behavior that lets it self-diagnose and let the operator know if it has a problem. So that trust you were talking about, that's a really important part of that, is being able to trust the test system before you even hook it up to the thing being tested.
So it's doing the troubleshooting, not the operator with a manual trying to figure things out.
Right. So whenever possible, hooking up cables to loop back signals and then hitting a button that says test yourself and let me know how you're doing.
Yeah. So self-test goes hand in hand with calibration and self-calibration. What does that mean as it pertains to missile test systems?
Yeah, so some of these systems that we're building may have hundreds or thousands of channels. So calibration can be a very big challenge in that. And it's obviously, being a piece of test equipment, it has to be calibrated and has to be trustworthy that the signals you're getting are, good measurements. So one thing that we try to design in where possible is what we call in situ or in place calibrations. And that means having onboard equipment like a calibration standard that's on board that can be used to calibrate, let's say, 100 channels or 1,000 channels all by itself and in an automated way. And we've been able to design this into most of these systems, like we did a system for the F-35 system integration facility. That system is 5 very large racks of equipment that each can calibrate itself in place. And all you do is send out a power supply and a precision DMM once a year to your NIST traceable lab for doing that. And that can run, typically very fast if it's in place like that. We can also do calibration verification. So in the case where you're not actually calibrating the system, but you're maybe verifying to a little bit larger span of operation, and it just gives you a little bit more confidence that, the system is still working as designed.
Good. Yeah, thanks. Yeah, in the Marine Corps, I spent a lot of time working on new equipment and some really old stuff. And the stuff that becomes obsolete over time has got some inherent issues, but it's inevitable. It's going to become obsolete, and modernization is absolutely key. What are some of the drawbacks to delaying that modernization and getting rid of that obsolescence?
Right. Yeah. So we probably all experienced that in a computer system, right? Your OS goes obsolete, and all of a sudden you're faced with drivers that don't work or hardware that you were using that no longer can work because the operating system got upgraded, and boom, it's dead, right? So that is going back to that trend of going to more off-the-shelf hardware and software. That's one of the challenges that gets created, is that when those changes get made and that migration happens, you end up with things that are broken at the expense of moving forward. So, or I guess with the benefit of moving forward, but it has the drawback of breaking things. So the military and aerospace in particular requires 15, 20, 25-year lifetimes on things. And so if you're just rapidly swapping out software and hardware, that's just not going to work. So one of the things that we do is discuss obsolescence with our suppliers at the beginning of a design, as opposed to waiting to the end and finding out that, oh, hey, this piece of equipment goes end of life in 2 years. So we try to be very proactive in the design phase for that. We design software in a very layered approach so that you can come in and insert things at different layers or replace things at different layers, and modernize that way without a lot of impact to your qualification. And also, even just something as simple as documentation, making sure that the document is the drawing is written saying things like, suitable replacements are allowed, things like that, if the form, fit, and function is there. Because sometimes in these designs, you get locked into the configuration that's there. And if there's not a little bit of leeway in the design, the future engineer supporting that system just doesn't have that latitude to make that change in the configuration. So even just something as simple as documentation can benefit, your approach to that can benefit you in the future.
Yep, thank you. Yeah, so as it pertains to missile tests, what do you think is one of the hidden benefits of some of the things that we've applied over the years at G Systems and utilizing a G Systems test system? What do you think one of those hidden benefits are?
Yeah, I would probably point to experience of our people as one of the big advantages, because we've seen a lot of different design patterns, both in software and in hardware. If you have gone down the wrong road enough times, you end up learning not to go down that road again. So we've learned some hard lessons that we can not do in the future and help our customers get moving forward. One thing too is, frankly, in the military and aerospace world, there are a lot of people moving out of the workforce and a lot of new people moving in, young guys fresh out of school. So we try to apply the lessons that we've learned to that and help them move along, lower their risk in their development, and get them jump started more quickly on the projects that they're doing.
Well, thanks a lot, Dave. It's been really good, and thank you guys for joining with us today. If certainly there's not enough time to talk about all the different things we do, but if you want to learn more about G Systems and some of the missile test systems we do, feel free to log on to gsystems.com. Feel free to reach out direct. We're here to help whatever your missile test needs are, or any automated test equipment of any kind. Hey, look, all we do is test systems. So, chances are if you do that yourself and want some help or advice, we're here to help. So thank you very much.